The 2K-12 Cub Mobile Surface-to-Air Missile System is a Soviet low-to-medium-level air defense system designed to protect ground forces from air attack. 2THSH-12 is the GRAU designation of the system. Each 2K-12 battery consists of a number of similar tracked vehicles, one of which carries the 1S90-125 kW GH brand radar, equipped with a continuous wave illuminator, in addition to an optical sight. The battery usually also includes 4 triple missile transporter erector launchers, and 4 trucks, each carrying 3 spare missiles and a crane. The TEL is based on a GRAU-578 chassis, while the 1S91 radar vehicle is based on a GRAU-568 chassis, all developed and produced by MMZ. Development. The development of the 2K-12 was started after July 18, 1958 at the request of the CPSU Central Committee. The system was set the requirements of being able to engage aerial targets flying at speeds of 420 Euro 600 AMS at altitudes of 100 to 7000 AM at ranges up to 20 km, with a single-shot kill probability of at least 0.7. The system's design was the responsibility of the now Tikhonov Scientific Research Institute of Instrument Design. In addition to NIIP, several other design bureaus were involved in the creation of the Cub missile system, including the now JSC Mitrobag. Each designed and produced the chassis of the self-propelled components. Many of the design bureaus would later go on to cooperate in the development of the successor to the 2K-12 Cub, the 9K-37 bike. First trials of the missile system were started at the end of 1959 to discover a series of problems: low power for the missile radar seeker and badly designed nose cone, missile air inlets design failure, low quality of heat shield inside the afterburner chamber. Those failures resulted in some org changes. In August 1961, Toropov was replaced by Lyapin as the chief designer of Gainful, and in January 1962 Tikhonov was replaced by Figorovsky as the chief designer of NIIP. Still, the work wasn't intensified. Before 1963 only 11 of 83 missiles fired had the seeker head installed, only 3 launches were successful. Cub downed its first ever air target on February 18, 1963 during the state trials at Dongyu's test site, Orenburg Oblast. It was an Ilyushin Il-28 bomber. The system entered an extended testing period between 1959 and 1966. After overcoming the technical difficulties of producing the 2K-12 Cub, the system was accepted into service on January 23, 1967 and went into production that same year. It is sometimes claimed that the M11 Storm naval system is a version of the 3M9, but this is not the case, as the M11 Storm is a separate system and, unusually for Russian surface-to-air missiles, has no land-based variant. The 2K-12 Cub was recommended for modernization work in 1967 with the goal of improving combat characteristics. A modernized variant underwent trial testing in 1972, eventually being adopted in 1973 as the Cub M1. The system underwent another modernization between 1974 and 1976, against the general combat characteristics of the system were improved with the Cub M3 clearing testing and entering service in 1976. After the chief designer Ardalian Rostov visited Egypt in 1971 to see Cub in operation, he came to the certain conclusion for the development of a new system, called Bike, where each TEL should have its own fire control radar and is able to engage multiple targets from multiple directions at the same time. The final major development of the Cub missile system was achieved during the development of its successor, the 9K-37 bike in 1974. Although the bike is the successor to Cub, it was decided that both systems could share some interoperability. The result of this decision was the Cub M4 system. The Cub M4 used Cub M3 components which could receive fire control information from the 9TH310 transporter erector launcher and radar of the 9K-37 bike. The advantage interoperability was an increase in the number of fire control channels and available missiles for each system, as well as a faster service entry for bike system components. The Cub M4 was adopted into service in 1978 following completion of state trials. Some early development interpretations of bike missile system heavily utilized the Cub components, including the 3M9 missile. there are several plans to integrate active radar homing missiles into CUB. For instance, Polish WZU of GRAU shows a project of Sparrow-armed CUB at the MSPO 2008 Defense Exhibition in Kielce. It is reported also that Gainful initiated some work to use its AVVA air-to-air missile to modernize the Kvadrant SAM system. Also, the Czech company RETIA presented a SURN upgrade featuring an optical channel and new multiple function color displays as well as the radar upgrade in the IFF system. In 2011 a CUB upgraded launcher with 3 Aspide 2000 missiles in launch containers was presented on International Exhibition of Defense and Security Technologies Exposition in Brno. The modifications were made by Russia. Description: the 2K12 system shares a lot of components with the 2K11 GRAU system. In many ways they are designed to complement each other. 2K11 is effective at long ranges and high altitudes, 2K12 at medium ranges and intermediate altitudes. The system is able to acquire and begin tracking targets using the 1S91 TH degree TH 1 quarter TH 3 quarters N TH 3 quarters TH 1 half TH degree NN florin NN TH degree TH 1 half TH 3 quarters TH squared TH degree N euro TH degree TH squared TH micron TH 1 half TH degree TH squared TH micron TH 1 half THN at 75 km and begin illumination and guidance at 28 km. IFF is also performed using this radar. It can only guide 1 or 2 missiles to a single target at any time. The missile is initially command-guided with terminal semi-active radar homing, with target illumination provided by the straight-flash radar. Detonation is via either the impact or proximity fuse. On the latest models, this vehicle is also fitted with an optical tracking system which allows engagement without the use of the radar, in which case the effective altitude is limited to 14 km/46,000 AFT. The optical tracking method also allows engagements to altitudes below that where the radar is able to track targets. Maximum target speed is around Mach 2 for head-on engagements and Mach 1 for tail chase engagements. Top speed of the missile is approximately Mach 2.8. In contrast to the elaborate Patriot missile or even the simpler Hawk system fielded by U.S. forces, most of the system rides on 2-tracked self-propelled vehicles, rather than towed or mounted on trucks, and either the launcher or control vehicle can be set to launch in only 15 minutes after changing location. Missiles: the fairly large missiles have an effective range of 4 km and an effective altitude of 50 14,000 m. The missile weighs 599 kg and the warhead weighs 56 kg. Top missile speed is approximately Mach 2.8. The combined propulsion system 9D-16K included solid fuel rocket motor which, when burned out, forms the combustion chamber for a ramjet in a pioneering design, putting this missile far ahead of his contemporaries in terms of propulsion. The missile was fitted with a semi-active radar Seeker 1 SB4, designed by MNII Agate, which was able to track the target by Doppler frequency since the start. Later upgrades could do this before the start. Chief designer of the Seeker head was UN. Vekhov, since 1960, IG Akapian. In 1977 a new version, the 3M9M1 was created with 3 missiles fitted onto a different chassis, the 2K12 effective replacement, with an integrated Fire Dome missile guidance radar. For comparisons between the 2K12, 9K37, see the 9K37 bike entry. An earlier incremental upgrade saw the 2K12 missiles replaced with the 2K12E versions, and this system was known as Kvadrant. This name was derived from the most common arrangement pattern of the military vehicles of the 2K12 complex, when the 1S91 radar is located at the center and 4x2P25 TELs at the vertices of a square around the radar. Comparison: 1S91 radar. SURN 1S91 vehicle included 2 radar station, a target acquisition and distribution radar 1S11 and a continuous wave illuminator 1S31, in addition to an IFF interrogator and an optical channel. While one S-31 antenna was installed on the upper section of the superstructure and the one S-11 on the lower, they could turn around independently. To make the height of the vehicle lower, the central cylinder was able to hide inside the prime mover. The acquisition range of the radar was reported as 50 km for the Phantom II type target. Total weight of the 1S-91 vehicle with a crew of 4 was 20.3 tons and 2 P-25 vehicle with 3 missiles and a crew of 3 was 19.5 t. Additional radar, the 2K-12 can also be used at a regimental level. If used as such, it can be accompanied by a number of additional radar systems for extended air search at longer range and lower altitude, to supplement the 1S-91 straight flush. These systems include the P-12 Spoon Rest, a VHF early warning radar, with a 200 km range. P-40 Long Track, an E-band early warning radar range. P-15 Flat Facer, a UHF early warning radar range. Thin-skin, or side-net E-band height-finding radar, scoreboard IFF radar, the Spoon Rest, and thin-skin are mounted on a truck, long track on a tracked vehicle and flat face on a van. It is unknown what kind of mounting the scoreboard has. Without the P-40 long track mobile radar vehicle, the 2K-12 is unable to track aircraft at high altitudes. Operational history: Middle East, Yom Kippur War. The 2K-12 surprised the Israelis in the 1973 Yom Kippur War. They were used to having air superiority over the battlefield. The highly mobile 2K-12 took a heavy toll on the slower A-4 Skyhawk and even the F-4 Phantom, forming a protective umbrella until they could be removed. The radar warning receivers on the Israeli aircraft did not alert the pilot to the fact that he was being illuminated by the radar. Once the RWRs were reprogrammed and tactics changed, the 2K-12 was no longer such a grave threat. The superior low-altitude performance of the weapon, and its new CW semi-active missile seeker resulted in a much higher success rate compared to the earlier SA-2 and SA-3 systems. While exact losses continue to be disputed, around 40 aircraft are usually cited as lost to SAM shots, and the 2K-12/SA-6 proved most effective of the three weapons. 1982 Lebanon War. The Syrians also deployed the SA-6 to Lebanon in 1981 after the Israelis shot down Syrian helicopters near Zallah. Copyright. The SAM batteries were placed in the Bekaa Valley near the Beirut-Damascus road. They remained close to the existing Syrian air defense system but could not be fully integrated into it. Early in the 1982 Lebanon War, the Israeli Air Force concentrated on the SAM threat in the Bekaa Valley, launching Operation Mole Cricket 19. The result was a complete success. Several SA-6 batteries, along with SA-2s and SA-3s, were destroyed in a single day. While Syria's own air defenses remained largely intact, its forces in Lebanon were left exposed to attacks by Israeli strike aircraft for the remainder of the war. Angolan Civil War. Cuban air defense placed hundreds of SA-2, SA-3 and SA-6 missile sites in the border with Namibia with the purpose of downing Buccaneer and Canberra bombers, particularly since they could carry nuclear weapons. And 3 M9M3 missile launched from a Cuban SA-6 hit a South African Impala Mk2 light attack aircraft that was mistaken for a Mirage F-1. Poland. On August 19, 2003, a Polish Air Force Su-22M4K was accidentally shot down by friendly fire during an exercise by a Polish SA-6 battery. The aircraft was flying 21 km from the coast over the Baltic Sea near Ustka. The pilot, General Andrzej Anzydowski, ejected and was rescued after 2 hours in the water. He subsequently died in a C-295M crash on January 23, 2008. Libya. The system was deployed by Libya during the border dispute with Chad and proved a threat for French aircraft. However, on January 7, 1987, these were successful in destroying an SA-6 radar site in the Fauligo area with Sepekhat Jaguars armed with Martel anti-radiation missiles. In March, the Chadian rebels captured Amadi-Doum Air Base and captured practically the whole heavy equipment used for the defense of this airfield intact. Most of this equipment was transported to France and the USA in the following days, but some SA-6s remained in Chad. With this catastrophe, the Libyan occupation of the northern Chad and the annexation of the Ozo Strip was over. By March 30, also the bases at Famalugo and Ozo had to be abandoned. The LARAF now has got a completely different task. Its Tu-22Bs were to attack the abandoned bases and destroy as much equipment left there as possible. First such strikes were flown in April, and they continued until August 8, 1987, when two Tu-22Bs which tried to strike Ozo, were ambushed by a captured SA-6 battery used by the Chadian army, and one of the bombers shot down. Libyan air defense, including SA-6 batteries, was active during the 2011 military intervention in Libya. They were completely ineffective, not managing to shoot down any NATO or Allied aircraft. Iraq, several SA-6s, along with other SAMS systems and military equipment, was supplied to Iraq before and during the Iran-Iraq War as part of large military packages from the Soviet Union. The batteries were active since the start of the war in September 1980, scoring kills against U.S.-supplied Iranian F-4 Phantoms and Northrop F-5s. Cub systems were active again during the 1991 war. On January 19, 1991, a USAF F-16 was shot down by an SA-6 during the massive Package Q strike against a heavily defended Baghdad. It was combat loss number 10 in Operation Desert Storm. The pilot, Captain Harry Mike Roberts, ejected safely but was taken prisoner and freed in March 1991. The aircraft was on a mission to attack the Air Defense Headquarters building. It had flown 4 combat missions before being lost. 2 days before, a B-52G was damaged by either an SA-6 or an SA-3. In any case, the SA-6 threat was largely controlled by Allied EW assets together with the older SA-2 and SA-3 missile systems. Most of the losses were due to IR-guided SAMs. Cubs continued to be used by the Iraqi military, along with other SAMs systems, to challenge the Western-imposed no-fly zones during the 1990s and early 2000s. They weren't able to shoot down any coalition aircraft, though several sites were destroyed as retaliation. For example, on December 30, 1998, an SA-6 site near Talil fired 6 to 8 missiles at aircraft enforcing the Southern Watch component of the NFZ. American F-16s responded by dropping 6 GBU-12 laser-guided bombs on the site and also launching 2 HARMs as a preemptive measure to warn Iraqi radar operators against carrying out more firings. Bosnia and Kosovo, Army of Republika Srpska forces, using modified SA-6s were successful in shooting down Scott O'Grady's F-16 in 1995 and 2 to 3 Croatian AN-2 aircraft that were used as night bombers with improvised 100 kg bombs. One Mi-17 was shot down by a Cub on May 28, 1995, killing the Bosnian minister Irfan Ljubijankia, a few other politicians, and the helicopter's Ukrainian crew. During the Kosovo War, in 1999, on the first night of the war, a Yugoslav Air Force MiG-29 flown by Major Predrag Milutinovic was downed by a Cub battery in a friendly fire incident, while approaching Nia Airport after an unsuccessful engagement with NATO aircraft. The Yugoslav Air Defense had 22 SA-6 batteries. Using shoot-and-scoot tactics, the self-propelled ground system demonstrated a good survivability with only 3 radars lost in the face of nearly 400 AGM-88 shots, but the system proved to be very ineffective, having fired 477 missiles without a single success, at the same time. As comparison, the fixed SA-2 and SA-3 sites demonstrated a similar low-rate success, but suffered losses to around 66 to 80%. According to the then Commander of Air Force and Air Defense General Spisosh Smiljanja, 2K-12 Cub had 46 shooting with 70 rockets. Of the 20 missile battery fired, only 16 battery affected, with material evidence, 2 unmanned aerial vehicles. And by assessment of conditions and the elements of fire hit 13 planes and 2 helicopters. Operators. Modern, Algeria, about 42 THSH-12S, as of 2012, Angola, 25 THSH-12S, as of 2012, Armenia, Bosnia and Herzegovina, 22 THSH-12S, as of 2012. a Cuba a €25 plus, a Czech Republic a €4 batteries, a Egypt, 56 2K12s, as of 2012, a Hungary, 16 2K12s, as of 2012, a India, 182 K12s, as of 2012, a Iran, a Kazakhstan, 22 K12s, as of 2012, a Libya, a North Korea a Romania, 8 batteries, future upgrading expected and proposed, a Russia a 1 battery 2 THSH-12s deployed in the Armenia, as of 2012. Also in service is IVC-3M20 M3P9 missile training target imitator system, a Serbian Army, 77 2 THSH-12s, as of 2012, Serbian Air Force and Air Defense, 9 2 THSH-12s, as of 2012. A Slovakia, 4 2 THSH-12s with C2 Tatrapan PVO, a Syria, 195 2 THSH-12s, as of 2012, a Tanzania, 22 K12s, as of 2012, a Ukraine, a Vietnam, a Yemen, former operators, a Chad, a Czechoslovakia, a East Germany, retired after German reunification, a Iraq, a Poland, a Soviet Union, passed on to successor states, a Yugoslavia. Bibliography, International Institute for Strategic Studies. Hackett, James. The Military Balance 2012. London, Routledge. ISBN A978-1857436,426. Sources. External links, Cub System Walkarounds, Cub 3M9 at Federation of American Scientists website, Needles in the Haystack, Hunting Mobile Electronic Targets, Major Michael Pietroccia, USAF, Radar sites near the North Gate, photos of Soviet radars at Area 51 North Gate, photos of Polish Cub.